In this session, we discuss and learn the structure. That is, structure is a user-defined data type. So, ordinary variable can store only one value at a time. Array variable can store more value at a time. Such values should be same data type. If we declare integer array for 5 locations, like integer a of 5, so it allocates 5 locations, but each location has stored integer value only. In first location we store integer, and second location we cannot able to store float. All locations should be stored integer value. So structure variable can store more value at a time like array, but such values may be different data types. So ordinary variable can store only one value at a time. Array variable can store more value at a time, but such values should be same data type. Structure variable can store more value at a time. Such values may be the different data types. In structure variable consist of different data types. It may be consist of different data types. In a single variable, we can store more value. It may be different data types. So this is a structure definition. That is structure of structure. Structure. Then we give name. It is a user defined name. So struct is a keyword. This is a name given by user. So opening brace, closing brace, put semicolon. This is a structure definition. From struct to closing brace, semicolon. This is structure definition. This is a structure name. That is name of structure. Within a braces, that is opening brace, closing brace, we can declare variables. As per our requirements, we declare different type of variables within this block. So these variables are called as elements. So these are all the elements of structure. This one is the name of structure. Then we declare the structure variable. Just to put keyword struct. Then we give the name. That is already a defined name. Then we put this name. The time of declaration struct, that structure name, then variable names v1 comma v2. So this is the declaration of structure variable. So this one is a definition of structure. In definition of structure, so this is structure name. These are all elements of structure. This is a declaration of structure variable. Each variable can store different type of values. Example, struct book. This is a name of structure. This is a body of structure. Integer ID, character bn of 40, float price. These are all the elements of structure. The structure name is book. Then struct book a comma b. It is a declaration of structure variable. A, b are structure variable. So that structure variable A is stored 3 kind of data types, 3 kind of values. One is integer, then string, third one is float. B also consists of 3 locations. That is 3 variable. In this location we can store different data types. That is memory mapping for structure variable. If we declare like structure book, character ID, float price, integer basis. This is the structure definition. This is structure definition. Here we declare the declaration and initialization. That is static character book b1 equal to b 130 550. 130.00 This is the structure declaration and initialization. The first line, that is static structure book B1 equal to B 130.00550. This is the structure declaration and initialization. So this circle mark this line. So it is unaligned. So static structure book B1 equal to B 130.550. This is a structure declaration and initialization. Structure variable declaration and initialization. Then that values B is assigned to B1 dot B variable. B1 is a structure variable. B1 is a structure variable. That B1 consists of 3 locations. One for character location, the second one for float location, and the third one for integer location. That location name is B1.id, B1.price, P1.pages. In structure definition, totally 3 elements is there. Within the structure definition, we declared 3 variables. That is, these are all elements. So in B1 consists of 3 elements. That is 3 locations. B1.id, B1.price, B1.pages. So in this line, we initialize at the time of declaration. This line we initialize the value at the time of declaration. So that B is assigned to B1.id. 130.00 assigned to B1.price. And 550 is assigned to B1.pages. The structure variable, the address of structure variable. It start with 1000. For example, it start with 1001. Just we assume that 1001. So the first element's location is the address of first element is 1001. So it is a character. So it occupies only 1 byte. So the next location is B1.price. The address of B1.price is 1002 because only one byte is occupied by character type. So 1001, then 1002 is the starting address of B1.price. So 1002, 1003, 1004, 1005 because it is a float. So it occupies 4 bytes. Then 1002 plus 4, 1006. 1006 is the address of B1.pages. So it allocates continuous memory. Maybe it independent of number of elements, it allocates continuous memory locations. Then printf address of name equal to %d and b1.id. If just we put b1.id, it refer B. b1.price, it refer 130. b1.pages, it refer 550. And b1 of id is 1001. And p1.price 1002. And b1.pages 1006. Here we put and b1.id. So address of name equal to, what is the output of this program? Address of name equal to 1001. Address of price equal to 1002. Address of pages equal to 1006. This will be the output of this program. Structure definition and declaration. We can declare, that is we define and declare in different way. The 4 definitions and declarations are equal. For example, just structure book, a character id, float price, integer pages, static struct book at the time of initialization. It may be array initialization or structure initialization. That should be the static data type or external data type. If we declare and initialize simultaneously, we done both of declaration and initialization. We must put static or external storage class specifier. In array is also we use static to initialization at the time of declaration. So here static structure book B1 equal to B 130.00550. So we also write like this. structure. Here the book is not there. The name is missing. Here just keyword is there. Struct. We remove book. Character ID, float price, integer pages in before semicolon. This is a semicolon is a typo. It's record semicolon here. Closing brace, it's record semicolon. In that before semicolon, we can assign that value. B1 equal to B 130, 550. So both are equal. It's not record name. At the time of declaration and initialization within the semicolon, that is before the semicolon, we no need the name of structure. Just directly we declare and initialize it. Then structure book character ID float price, structure book B1, B2. It is a normal declaration only. Here we declare the variable. It is equivalent to this definition declaration. Structure book character ID float price integer pages B1 comma B2. That is just before we put B1 comma B2. So we also remove the name. If we declare or declaration and initialization simultaneously in before the semicolon, we no need the name. The structure name is not required. Array of structure. We also create an array for to store the structure. For structure, we can create array of structure. So ordinary variable can store only one value. Array variable can store more value. Structure variable can store only one records, that is one group of value. If we want to store more records, that is more group of value, the structure array is required. Structure book character ID float BR integer PG. So structure book B of 3. This is a structure array. That is array of structure. The variable name is B, but it has 3 structure locations. Each location consists of 3 elements. Each location can capable to store 3 values. Integer L, print enter the name, page, price, pages, price. So for loop rotate 3 times, that is 0, 1, 2. The first time is 0, percentage D, percentage D, percentage F, and B of 0. What is the memory mapping for that array of structure? B of 3. The total variable name is B. B of 0 consists of 3 locations. That is B of 0 dot ID, B of 0 dot price, B of 0 dot PG. Then B of 1 is a next location of structure array. B of 1 also consists of 3 locations. B of 1 dot ID, B of 1 dot price, B of 1 dot PG. B of 2 is a third location of structure array. B of 2 dot ID, B of 2 dot price, B of 2 dot PG. So the addresses is in continuous form, like on the array. Array is also, array addresses are in continuous form. So to allocate continuously. Structure array is also allocate continuously. That is 700. Is a 0th location. Starting address is 700. 707 is a first B of 1 location address. 714 is a B of 2 address. But B of 0 consists of 3 locations. One for character, next for float, and third one for integer. So how many bytes is required? Character 1 byte, float 4 bytes, integer 2 bytes. Totally 1 plus 4 plus 2. Totally 7 bytes is required. So B of 0, the size of B of 0 is 7 bytes. So the address is start with 700. So 7 bytes is required. That is 700, 701, 702, 703, 704, 705, 706. 700 to 706 is a 7 bytes. It is a B of 0 locations. Then B of 1 also has 7 bytes because it consists of 3 elements. One is character, float, and integer. B of 2 is also consists of 3 locations. The size is 7 bytes. So based on that address, that is 700 is a character location. It is 1 byte, it occupied 1 byte. Then 701, it occupies 4 bytes because it is a float. 701 plus 4, 705. So then the p of 0.pg is an integer. It occupies 2 bytes, 705 and 706. So it starts 707. So the addresses will be in continuous form. Then first the value of I is 0 and b of 0.id, because it is a character type. This element is character. Here we put %c, %d, %f, because pr is a float, pj is an integer. So based on that we give the appropriate format specification here. So b of 0.id, it get one value. For example, it display enter the name, page, this and price in output. So then the cursor is way to accept the input. If we type A 455.0 300, so that A is assigned to b of 0.id. In b of 0.price, it assigned 455.0. In b of 0.page, pg, it assigned 300. So the loop continue. Now I change as 1. So b of 1 and b of 1.id. So the next input b. That b is assigned to b of 1.id. Then b of 1.price 750, b of 1.page 550. Then continue the loop. Now the value of I is 2. So b of 2.id. So c is assigned to b of 2.id. 350.0 is assigned to b2 of price. Then 425 is assigned to p2 of pg. So this is the input. So these values are stored at location, appropriate locations. So then another for loop to display the value. I value is 0, b of 0.id, b of 0.price, b of 0.pg. So it get and display that value from b of 0, b of 0 id a, price, page 500. Then loop continue. I is 1, b of 1.id, b of 1.price, p of 1.pg. So then continue. The new value of I is 2. So display the third set of values. And it continue. The value is 3. I value is 3. 3 less than 3. The condition is false. It come out the loop. Then in this closing brace is a main function closing brace. It will terminate the program. Passing structure element to function. Through this example, we pass the structure element to a function. So structure book, character name of 25, character author of 25, integer call number. So what is the total size of that structure? The 25 bytes because it is a character. 25, 25, 50. This is a 2. So 52 bytes. The structure size is 52 bytes. Here we declare and initialize the value. Static struct book B1. B1 is a structure variable equal to C and C++. That C and C++ is assigned to name. B1 dot name. In B1 dot name, it is a B1 memory mapping of B1. B1 consists of 3 locations. That is B1 dot name, B1 dot author, B1 dot call number. B1 dot name consists of 25 bytes. So P1 dot author occupies 25 bytes. P1 dot call number it occupies 2 bytes. So totally 52 bytes. For example, it starts with 800. We assume the starting address of that B1 structure variable is 800. So it starts with 800. The first location is 25 bytes. So it occupies 25 bytes. 800 plus 25. So 800 to 824 is the location, the 0th location. That is first location. That is B1 dot name location consists of 800 to 824. Then its second one is start with 825 to 849. Then 850 to 851. So this is the address. It is allocated continuously. So the C and C++ is associated to B1 dot name. Then B1 dot author, the soft text is assigned in P1 dot author. So the 108 is assigned to B1 dot call number. Display is a function. We pass 3 arguments. that arguments are elements of structure. B1 dot name, B1 dot author, B1 dot call number. Already we stored 3 values to the 3 elements. That is B1 dot name is C and C++, P1 dot author, P1 dot call. We pass 3 elements to the display function. This is calling function calling. This is a function definition. So we pass 3 arguments as actual argument. So in formal argument, n comma a comma c, this is a formal argument. So b1 dot name is a character. So name, this is array. b1 name is a array. If we b1 dot name, it will give the address of that base, address of that array, that is starting address of that array, that is base address of that array, b1 dot name, that is 800. That 800 is a character address. 800 is a address of character. So in formal argument, we declare as character pointer variable. Then b1 dot author, it also represents the starting address of that array. So 825, this is also character address. So in receiving area, that is formal argument, the a is also a character pointer variable. So n is character pointer, a is character pointer because it receive character array address. A is also receive character array address. C is an integer because b1 dot call number is an integer. So just we declare C as integer. Print a percentage n comma a comma c because that 800 is transferred to location of n. 825 transferred to location of a. 850, that is 108. So we are not passing address. Here we pass value because this is array name. So if we give b1 dot name, it return it pass the address, base address. b1 dot other, it is also a array. So the address b1 dot call number is a integer. So it transfer only 108. Percentage d. N has 800. If you put percentage c, it will display character of 800. If we put percentage d, 800. If percentage s, it will display the string of 800. That is what is the string of 800? C and C++ is a string of 800. So it will display C and C++, then soft tag, then 108. This is the output of the program. So we can pass the elements of structure to the function. Passing entire structure to function. Structure book. So character name of 25, character author of 25, integer call number. So this is a global definition. Here we define before the main function. This is global definition. If we want to pass entire structure to a function, we must define the global. We must define as global definition. So just we define before the main function. This is global definition because in previous program we pass element by element. Element by element, it's not required to define a global definition because we pass element by element. But here we pass entire structure to a function. So the actual argument is structure variable. The formal argument is also a structure variable. If we define within a main function, it is local to main function. We only declare structure variable within main function only. We cannot able to declare out of the function. But we want to pass entire structure to a function. At the time of passing, we pass structure variable. At the time of receiving area is also it should be the structure variable. So that's why we define that structure as a global definition. So main function start is struct book b1 because it is a global definition. We can use that struct book in this function. This function it is a global one. We can use in all function of the program. So static structure book, because declaration and installation both are in same statement, so we must use the static storage class specifier or external storage class specifier. So here we use static struct book b1 equal to c and c++ softtext 108. So this is a memory mapping for that. This is a b1 variable b1. So it consists of 3 elements. So that 3 location b1 dot num, b1 dot author, b1 dot call number. This is 25 bytes. This one is 25. This is 2 bytes. Totally 52 bytes. The size of b1 is 52 bytes. For example, we assume the starting address of that structure b1 is 800. So the first is 800 to 824. Totally 25 bytes. Then it start with 825. b1 dot author is start with address of 825. So it's 849. 825 to 849 is 25 locations. Then b1 dot call number start with 850 because it is integer. 850, 851. The address of b1 dot call number is 850. So it allocate continuously. Then it initialize that value in that appropriate elements. That is c and c++ for b1 dot name. Softtext for b1 dot author, 108 for b1 dot call number. Here we call the function. So the argument is b1. b1 is a structure variable. In previous program, b1 dot name, b1 dot author, comma b1 dot call number, we pass element by element. But here we pass entire structure. That is b1 is a structure variable. In receiving area is also the same data type. That is in previous program we pass b1 dot name. It is a character. Address of character, so we declare integer, there is character pointer variable. b1 dot author is the address, we declare pointer. Then call number is integer, we declare integer variable. So 2 character pointer variable, 1 integer variable we declared in previous program, because we pass element by element. In this program we pass entire structure. b1 is a structure variable. So in receiving area, that is in formal argument also, b2 we declared b2 as a structure variable. So then only it pass b1 values to b2, because b1 consists of 3 values. So what is the memory mapping of b2? This is a b2. For example, we assume 900 is a starting address, 925 because 25 bytes, then 950, this is 25 bytes. So these are the address. So b1 is transferred to b2. Just copy the all elements value to the formal arguments. That is b1 dot name is automatically transferred to b2 dot name, b1 dot author, b2 dot call number. So the b1, the value of b1 is transferred to b2. So now b2 consists of the same value, c and c++ softtext 108. Just we display through printf percentage d, p2 dot name, p2 author, p2 dot call number. The same value is displayed here. This is the output of the program. We can pass the entire structure to the function by using global definition.